Welcome to Geek Do-It-Yourself Mechanic. The purpose of this video is to discuss the automotive relay. My goal is to give you a high-level view of how it functions and some examples on how it can be used. It's used from controlling your headlights to turning on and off actuators to even turning on and off your fuel pump. It's something you're going to encounter. They're either going to go bad or you'll need to interact with one, a relay that is, to test components in your car. So having a good understanding of what a relay is, I feel is important. Let's begin. Let's go to Knowledge, Electronics, Electronics Concepts. And let's go to the Relay panel. Again, in this video, we're going to leverage Paul Falstad's Java Applet Analog Circuit Simulator. It allows you to see circuits, see what's going on, and to visualize circuits. I just find it incredible. It really helped me learn electronics. In your house, we have switches to our lights. If you've ever taken off the wall plate on a switch, you would have noticed how large the wires are. And it's because the switch is in series to the load. And in this case, we're going to pick this to a light, a lamp, or whatever. So that switch has to be able to handle the current of that circuit. So if it's a 15 amp circuit, that switch has to be able to allow 15 amps to pass through it without generating excessive heat. In addition, the wires going through the switch have to be able to handle that current. It's just that simple. Houses can be up to 20 to 30 amps. Now let's convert that discussion into your automobile. If you've ever worked on your car, you'll notice most of the wires are not of that gauge, that big, that thick. There are some, like the grounding strap to the frame, the positive connection between the alternator and the battery, the positive connection between the battery and starter. But most of the other wires are not. And in addition, I mean, just think of the starter wire. It's pretty big. Or even the fuel pump gauge wire is pretty big gauge. But that's not inside your dash area. If you think about it, you have little ignition. Your key turns out. That's a little wire. Your headlights switch is usually very little, right? Especially nowadays, it's off the column. It's a switch off the column that you rotate. Those are very small wires. How do automotive engineers accomplish that? They use an automotive relay. This little picture shows it. What a relay is a switch used to control another circuit. So a lower amp, a lower current circuit is used to switch a higher current circuit. Well, don't feel bad if that seems confusing. When I first read about this and learned, I was like, what? Well, I hope I can help you get to the understanding quicker than it took me. What a relay inside looks like is like this. This is the schematic of what the insides of this relay looks like. It's really quite simple, but what you just need to remember is we're using one lower current circuit to turn on another higher current circuit. The lower current circuit is the coil. The coil's right here, between 80 pins 85 and 86. So when current is allowed to pass, so one of them will have to be positive, one of them is ground. When that circuit is complete, current will flow through this coil, creating a magnetic field that pulls this lever to 87. So that would allow current to flow from 30 to 87. Well, let's see how that works by going into the simple relay example. This is the simple relay. This is exactly what we saw before. Pin 30, 87A, 87, 86, and 85. Those are the same pins showed in that schematic. Well, let's go through that. So this is the coil. When this coil energizes, it's going to move this contact. When I allow current to go through this coil, a magnetic field is induced, and it'll pull, physically pull. You actually hear a click in a relay. And by the way, just because you hear a click doesn't mean the relay works. But a working relay does click. So again, when current goes through this coil, it's going to pull this contact down and allow 30 to connect to 87. So what we would expect is 5 volts will go through 30, through 87, and through this load. In this particular case, it's an LED. It's because the simulator didn't have anything else of greater load. At least I couldn't find one. So let's see what happens. Let's say you turn on your headlight switch. There it goes. What's going on? Current flows through this coil and out to ground. So again, the coil, this coil inside, must have a positive and a ground, because it needs current flow to induce a magnetic field that physically pulls down this relay connector connecting 30 to 87. What's this 87A? 87A is the normally off position. So let's look at it. When I turn off the relay, meaning I stop current through the coil, that by spring is pulled back and allows 30 to go to 87A. So that would allow you, I'm just making up an example here, if you want it to be, you want all your red lights in your car to be on when your ignition is off. Of course, you would never want that, but just bear with me in an example. But when you want it on, all your green lights would be on. From my experience, most of the time, cars don't use 87. Many times, the relay will be missing the center post, which I believe is 87A. Let's go on to a more realistic example I pulled out of a schematic from a car. This one's a little more complicated. Let's study it. Here's the battery going into 30. This is pin 30. Pin 86 is here. Pin 85 is down here. 87A, remember that's relay normally off. And 87 when it's in on. So in this case, when the relay is off, notice this is open. There's no current going through this coil. Therefore, there is no magnetic field present. Current is flowing through 30 to 87A, in this case, to a red LED. Well, let's turn on the relay by using an external pull-up control. Pull up. Notice this is at ground. I'm going to pull it up to voltage. Current flow is now through the coil. A magnetic field is created, pulls down this contact connecting pin 30 to 87, and now the green light is on. Well, I just demonstrated a pull-up technique for the relay. Let's try a pull-down. So if I disconnect that, now it's in a pull-down configuration. Notice there's power through the coil, but there's no current flow. Remember, there's no voltage drop. This is at 5 volts. There's no voltage drop across the coil or the resistor because there's no current flow. Now, the state of the relay is just like in the pull-up configuration when it was off. The relay, there's no current in the relay, therefore no magnetic field is present, and the connector is in the normally off position, again allowing current to go from 30 to 87A to the red light. But if I engage the pull-down side of the circuit, now I have flow through the coil, magnetic field pulls down the connector, 86 is connected to 87, and it now is in the on state. Many times in cars, they won't connect anything, like I said before, to the 87A. So this is normally what occurs, and I'll just turn it off by the pull down side, just for random. Could be the pull up as well. No current is flowing to 87A, nothing is occurring. But again, most of the relays I see, 87A pin isn't even there. Well, I hope the simple explanation up front in the introduction, allowing you to see the simple relay diagram and then seeing one real-life example of how a relay could be connected, again showing it can be controlled with a pull-up circuit or a pull-down circuit, helped you understand relays a little bit. I hope you log onto the website and try these and play with them to get more hands-on experience. Thank you for watching. I hope you found the information helpful.